Okay, we're live.
Okay, we start exactly at 5:01. There's always a time lag.
Okay, I'll go ahead. So, good evening, everyone. We thank you for joining us on the occasion of National Science Day this year. I am Spatika from the Indian Institute of Science, Education and Research, Mohali. And on behalf of our team, I would like to welcome all of you to the launch ceremony of our Inter-Institute Science magazine, Inventa. Inventa is a first of its kind venture that also serves to be a youth led science communication platform developed through the collaborative efforts from students at the 7 Indian Institutes of Science, Education and Research, the Center for Excellence in Basic Sciences, the National Institute of Science, Education and Research, and the Indian Institute of Science. With the COVID-19 pandemic, that has been well talked about and is often all that is being talked about, the past year made us face elements of nature, technology, and humanity that we weren't ready for. It was amidst this flux of information that we students from across the nation came together to set up Inventa. As aspiring researchers, we also hope to bring forth the realities of a life and career in science through the means of this magazine to encourage more students to pursue this stream of higher education. The 2021 edition of Inventa also hopes to mark a moment in history characterized by the pandemic, its impacts on society, and the increasing wave of misinformation and pseudoscience that drove us to bring forth a communication platform catering to students and professionals alike. Today, we are honored to have Professor Sandhya Vishweshwaraya as the guest speaker for our launch ceremony. Professor Vishweshwaraya is a scientist and former chairperson of the Department of Molecular Reproduction, Development and Genetics, and currently the co-chair of the Center for Biosystems Science and Engineering at the Indian Institute of Science, Bangalore. She additionally holds the position of adjunct professor, Faculty of Medicine and Dentistry at the University of Bergen in Norway. Her research involves investigating signal transduction via cyclic nucleotides, phosphodiesterases, and novel cyclases in bacteria. She has been the recipient of several accolades, including a Bill and Melinda Gates Grand Challenges Explorations Grant, and is a fellow of the Indian National Science Academy and the Indian Academy of Sciences. We will also be hosting an interactive session after the talk today and encourage participation from the audience. So without further ado, please join me in welcoming Professor Vishweshwaraya.
Are you able to hear me now? Right. Thank you very much, Spatika, for your very kind introduction. And nothing gives a teacher greater pleasure than when a former associate in their laboratory, preferably a younger student, invites you to come and give a talk. I take it to mean that perhaps their stay in the laboratory wasn't so unpleasant that they felt they wanted nothing more to do with you in future. Now, this is also
Excuse
very
me,
unique.
Professor.
Sorry?
Hi, we are hearing it twice.
I can hear you twice as well.
Okay.
Oh.
Can everyone turn off their audio, please?
I think possibly there must have been an audio. Can you hear me now?
Yes, I can hear you fine now.
Yeah, and I can't hear an echo either.
No, actually,
Okay.
I can again hear twice.
Can you hear me now correctly?
I
Are you
can.
able to? Yeah. Okay. Should I go ahead?
So is it okay now?
Yes, it's fine for me.
No, it's repeating twice again. I can hear everything twice again.
I think it's fine for me, sir.
I think it's fine for the rest of us.
Yeah.
Okay, fine, go ahead.
All right. Yes, as I was saying, thank you very much, Spatika. And this is also a very interesting talk that you've asked me to give, because this is perhaps the first lecture that I've given where the title has been given to me by the organizers. We're so used to being asked about titles for our talks whenever we're invited to lecture. So going by the title that was delivered to me, I think I'm going to talk to you about very general things today, and which I hope are of interest to you as we go along. Now, as Spatika mentioned, the last year, I think, has brought to the front the importance of science in society and the role of science in today's world. What happened now? Oh, yeah. All of you in the audience, and at least many of you in the audience, are young people embarking on a career in science. And the question that I pose to all of you at this very early stage in your career is, will science and scientific approaches guide your actions in the years to come? Are there aspects of life, for example, that you think are beyond scientific understanding? And finally, is there now, or will there be in future, a life outside of science for all of you? Now, I know many of you are going to continue to pursue a career in science, but I'd also like to touch upon something towards the end of my talk, which suggests or proposes that every one of you, whether you're a scientist like me or have left science, to consider having activities in your lives that are outside of the scientific process. What is science? Now, I took this definition from the Encyclopedia Britannica, and I'm pretty sure that many of you in your first year of undergraduate studies would have had perhaps classes where teachers spoke to you of what science was. I like this definition because of a couple of words that I've highlighted. Science is any system of knowledge that is concerned with the physical world. What this means is it includes things like engineering, it includes things like medicine. And we've always, at least in this country, tried to separate the doing of science, the doing of medicine, and the doing of engineering. Ultimately, all activities which relate to the physical world around us are scientific activities. Let's go on with the definition. And it's phenomena and that entails unbiased observations and systematic experimentation. Now, what I've highlighted here are the two words unbiased observations. This becomes extremely critical when you're conducting experiments or you're observing the world around you. You need to be sure that the way you look at things is not based on any biases that you might have coming from your cultural background or your previous educational background. Now, in general, science involves the pursuit of knowledge, which covers general truths. Now, that's another very important word, truth, and the operations of fundamental laws. Now, all of us as scientists would love to make fundamental discoveries. That is, discoveries which shape the thought process of future generations in terms of what they may be doing. Again, a slide that again, perhaps many of you would have thought, the scientific method. The key ingredient of any scientist is observation or observatory powers. What we do is we look at the world around us and we ask ourselves the questions, why and how? Not necessarily when, that's left for historians to do. We assume that all the phenomena that we're seeing around us have been there from the beginning of time. When we may observe something which looks of interest to us, we then start collecting information and we start asking questions. We do a little bit of investigation and we formulate hypotheses. Following this formulation of hypothesis, we design experiments to test that hypothesis. And in many cases, the experiment, if your hypothesis is correct, works. However, in many other instances, the observed results that you get are actually very different to what you expected. Now, what do you do at that time? Many of my students come into my lab and say, Sandhya, the experiment didn't work. And I keep telling them that there is nothing about an experiment not working. It means that you may need to rethink how the experiment was done. So you have this back and forth between an experiment which gave you unanticipated results versus the experiment that gave you results that you expected. You keep comparing them, and hopefully at some point of time, you get results that you would expect had your hypothesis been correct. You then draw a couple of conclusions, And if the conclusions do not fit the hypothesis, you go back to the drawing board and you start all over again. And this is the process why science takes quite some time in doing. Many of you are extremely bright young kids and you're absolutely convinced that you'll finish a PhD in 1 year. It doesn't happen. And this is one of the major reasons that the thought process, as well as the execution of experiments, takes time and a level of understanding that usually spans out over many years. Finally, you draw some conclusions. And another very fundamental requirement of scientists is to report the findings. And that is why there is this apparent obsession to publish. You've heard terms like publish and perish. There is no point in you doing an experiment in your laboratory without sharing the information you get from that experiment with the general scientific community. During the process of publication, your work is peer reviewed by experts in your field. You will face criticism in many instances, more often than not. Your papers will be rejected. They will doubt your conclusions based on the limited number of experiments that you've done. Nevertheless, this is an iterative process again, and then hopefully one day your hypothesis or your finding is accepted in the form of a publication. And naturally, as a result of this important finding that you've made, you go ahead to conduct additional experiments based on this particular accepted hypothesis. Now, I borrowed freely from this particular website because I kind of liked it when it talked about the 9 main steps that scientists, or at least the doing of science, entails. First of all, you need objectivity. Scientific knowledge is objective. It is the ability to see and accept facts that are as they are and not the way that you might wish them to be. However much you may want something to be the way it may not always be the way that it is. And therefore, it's extremely important that you guard against your own biases, beliefs, wishes, values, and preferences. Now, all of these come from your cultural background. And scientists are not supposed to bring in any of these biases or beliefs in the interpretation of the results that they get. It's extremely important to remember that scientists, however, are human beings. And as a result, we of course will have biases. We of course will have beliefs. We of course will have values and preferences as to what we might want out of life. But they must in no way impinge on the scientific finding. Now, the next important aspect of science is verifiability. Your experiments or your evidence that you produce at the end of your studies must be validated by others. Other observers should be able to observe what you did, should be able to measure the same phenomena. And questions such as the existence of soul or the existence of heaven or hell or God for that matter, these are not scientific questions because we cannot answer them or treat them factually. And therefore, scientific knowledge must be based only on verifiable evidence. It's important to remember again as a corollary that science does not have answers for everything. It deals only with those questions about which verifiable evidence can be found, and it's extremely important that we understand this. Are we going to allow questions during the talk? I see someone with their hand up.
No, you can go ahead. We can
All
have
right.
a session after.
So now let's continue in terms of the 9 objectives of science. Ethical neutrality. Science is ethically neutral. All it does is want to increase knowledge around you. How this knowledge is used is dependent on the society in which the knowledge is identified. For example, you can use atomic energy for generating energy required for electricity, but you can also use the knowledge from atomic energy for making atomic bombs. What do? That is not science's concern. Science's concern is just identifying the facts and providing you the information. How this knowledge is used is determined by the country you live in, its value systems, more often than not, the value systems and ideas of the politicians who run such a country. Again, I reiterate, scientists are human beings, and you and I will have beliefs. Scientists must have values. Scientists are free to express their values, but these values must not impinge on the discoveries that they make. Now, another aspect about science is that it's a very systematic exploration. There is a process. You go from step 1 to step 2 to step 3 in a very organized or planned manner. And this is really what the role of supervisors are for young students, providing them the direction that they should proceed on in order to be able to make the discoveries that they wish to. Now, one feature of science, which is really the bane of most students, is reliability. Any discovery you make, you must be able to reproduce, not once, not twice, but many, many times. And it is this reproducibility that is critical to being able to say confidently that the discovery you have made is actually true. It must be reproducible anywhere in the world and at any time. And this is exactly some of these controversies that erupt in scientific literature from time to time, where people say that so-and-so made this huge discovery, but we are unable to reproduce it. Now, who is right and who is wrong is going to require investigations along similar lines by a number of other people before something is considered absolutely correct. Now, what about precision? Scientific knowledge is precise. You can't get away by saying something is more than something else, or your experiment showed that this particular mouse model had less blood sugar than the other. You have to say exactly and precisely what you mean. Now, this is a very nice example, again, from this particular website. Tennyson, I'm sure all of you have heard about the great English poet, Alfred Tennyson. He wrote most poetically, "Every moment dies a man, every moment one is born." Beautifully said, but it's not scientific. Now, if you wanted to say it scientifically, you have to say, in India, according to the 2001 census, every 10th second on average dies a man. Every 4th second on the average, an infant is born. Now, this certainly is not great literature. It is definitely not something you would read with great pleasure and marvel at the beauty of the language. But that's not what science is supposed to do. It just has to state things very precisely and carefully. Which brings you to the next demand of accuracy. Scientific knowledge is very accurate. It implies that you're speaking the truth and saying things exactly as they should be without jumping to unwarranted conclusions. Now, many of you are asked to critique scientific papers, which you will do during your studies. You will look at an experiment, you will look at the interpretation that the author has provided, and then you start critiquing it. You say, perhaps this observation could be explained by something completely different. Why did the author decide that this was the evidence that proved their point? And it is this ability to be questioned, this ability to allow others to look at your work, express their concerns, and not feel insulted by it, is a critical requirement of any kind of scientist. It is the need to have a very open mind and be prepared to receive input from everything and everyone around you. Now, the ultimate goal of any scientist is to be able to predict an outcome. And it has been said that once you understand something completely, you can predict the way it happens. Now, perhaps this is very true for scientific disciplines like physics, perhaps even chemistry. But biology is a slightly different kettle of fish. And while we know a lot about biology and biological phenomena, I don't think we're still in a space to be able to predict every single biological phenomena that happens around us. And the reason for that is not because there is magic or not because there is an unknown non-scientific force that drives biological phenomena. The fact is that we don't have enough knowledge. And many of us do believe that once knowledge is complete, we will indeed be able to predict biological phenomena. And finally, abstractness. Now, this appears to be contradictory to everything that I've said earlier. How can science be abstract? But science does proceed on a plane of abstraction. For example, at the moment that you're conducting your experiment or thinking about a problem, there is nothing in black and white written about it. You are abstracting information that you've had, and you're trying to come up with a theory. So science always begins on a plane of abstraction. And a general scientific principle is highly abstract. Think of Einstein. Think of the speed of light and time. Importantly, while it's necessary to communicate our scientific discoveries to non-scientists, in the scientific community, there is really no need to give a very realistic picture. Your findings must be as they are, stated in scientific language, which is understood by experts in your field. Now, of late, and many of you, I hope, will end up becoming translational scientists. Now, this is a very nice article that I came across as I was preparing for this talk, where it makes a distinction between researchers who work in labs to those who go on to become what are called translational scientists. In other words, scientists that utilize the discoveries of science to be able to bring them forward into human action or human behavior. What are the requirements for such an individual? He or she really needs to be a rigorous researcher. They have to be skilled in communication because they're going to be going around asking business people for funding to be able to take their idea ahead. They're going to have to be talking to scientists to make sure that their science is okay. They need to be a domain expert. What is it that you're making? If you're making a vaccine, it's important that you have the knowledge of what a vaccine is. I think many of us would feel extremely uncomfortable if the Ambanis just said that they had identified a vaccine and that they were going to inject people with it. Ambanis do what they do, and the Serum Institute in Pune does what it does. So that's called a domain expert. One of the things that I'd like to highlight on this particular slide is the word boundary crosser, or the words boundary crosser. What we tend to do in this country is compartmentalize the kind of science that we do. Are you an engineer? Are you a doctor? Are you a biologist? Are you a physicist? Are you a chemist? And it's as if these compartments operate independent of the other. Now, in institutions like the ICES and the undergraduate program in IISc, I do hope that such artificial boundaries are being broken down and that there is this cross movement of thought that the young people are exposed to, so that at the end of your 4 or 5 years in these ICES, you sometimes wonder, am I a biologist? Am I a chemist? Am I a physicist? I have a PhD student in my laboratory right now who joined from ICER. He was a student in ICER Bhopal. And we interviewed him in the bioengineering department. And it's only later that I got to know that his major in ICER Bhopal was in physics. Yet he is culturing cells, doing work that any biology student would do. And that is what gives me great pleasure, because it shows me that students in institutions like yours are able to adapt and transcend boundaries in the kind of science that they do. Many of you, as I said, will go on to industry and will go on to become translational scientists. And their role is as important, perhaps, as the basic researcher sitting in the laboratory. Now I want to touch about something which is very close to my heart. And the reason I'm bringing this up here in this particular community is that all of you are the future of science around the world, not just in India. And I'm addressing this talk not really to the women in the audience or the young girls, but I'm addressing this part of the talk to the young men or the young boys in the audience. And that is, I'd like to talk about the doing of science, which can be done by one and all, and the role of women in science. Now let's talk about bias in science. Remember, I told you that scientists should have no bias, but we're all human beings. Now, there was a paper that was published some time ago in the PNAS where scientists were presented identical resumes. The only difference is that some of the resumes had male names and some of the resumes had female names. And the reviewers were asked to evaluate the quality of the people who had applied for this particular job. And believe it or not, scientists rated those with female names significantly lower in competence and hireability, even though the resumes they were provided with were exactly identical to another scientist who received the same resume, but with a male name. You see the bias here? Nearly 30% of scientists in the US are women. Why is this the case? You know, many of you would aspire to go to Harvard Medical School. Did you know that women were excluded from Harvard Medical School till 1945? That's really not so very long ago. And Cambridge, the University of Cambridge in UK, would award degrees to women only in 1947. Now, it is these kinds of injustices that many women in science question. But women can't do it by themselves because it is still a male-dominated profession. And therefore, what we need are a group of men to realize that something is not okay. And that is why I'm talking to you about this at this point of time. Now, this is an excellent book, which really, if all of you can get hold of, I think it's available on Kindle. I had the hard copy, which interestingly was presented to me by a female student in my department. She wasn't in my laboratory. She came from some other laboratory and she gave it to me and she said, "Ma'am, I'd like to give you this book because you were a source of inspiration during my stay," which of course delighted me. But then when I read the book, essentially what she was trying to tell me is that she realized that women were not considered as competent as men in doing science. And in this particular book, Angela Saini describes innumerable instances where even though women conducted the science behind their discoveries, I'm sure all of you would be aware of Franklin's problem as far as the DNA structure was concerned, a number of instances where such kind of discrimination has come purely from bias. Take a look at this. This is a discussion between Charles Darwin, yes, the Charles Darwin, and an American feminist somewhere in 1881. She was a very strong advocate, Caroline Kennard, for the women's movement, and she was living in Massachusetts in the USA. And in a series of correspondence, because remember in those days, Zoom calls and things weren't available, they wrote letters to each other. She asked Darwin if it was true that the inferiority of women, past, present, and future, was based upon scientific principles. So in the 1880s, and I guess unfortunately in many parts of the world even today, women are considered inferior. And so she asked Darwin, is there any science behind this? And this is what he said, brace yourselves. Darwin responds, I certainly think that women, though generally superior to men in moral qualities, are inferior intellectually. And there seems to me to be a great difficulty from the laws of inheritance in their becoming the intellectual equals of man. Now, I hope, though I can't hear or see any of you, that all of you are gasping at such a statement from one of the world's most renowned scientists. He goes on to argue that if women were to become equal to men, they would have to become breadwinners. And what would that result in? Damage to households and the upbringing of young children. Now, Kennard, of course, did not accept this response, and she argued vehemently that women contribute as much to society as men do. And she argued that let the environment of women be similar to that of men with his opportunities before you can judge her fairly, intellectually, as his inferior. Now, as an aside, I think she spoke so vehemently for the cause of women in science that her sister set up a fellowship in Radcliffe, very famous college, where one female student every year is supported in pursuing her studies in science per year. Now, as far as women in science are concerned, there are trials and there are tribulations. There is this perceived bias that women are not as good at science and mathematics as are men. But of course, if you look at least in terms of school testing in the US, right up to the age of 16, girls perform as well as men in terms of math scores. So now you might ask, what happens later? Take a look at the classes that you're in right now. I know in IISc, the ratio of women in our undergraduate program is abysmally low. It is actually atrocious in this day and age. Why? Every year when the 10th or 12th standard results come out, girls always do better than boys. So what is it that prevents them from joining prestigious institutions for science education? Is there a problem with societal expectations? Are there issues with the way their parents view their role in society? Are these ideas so ingrained that even the young girl feels that she's not capable of doing science? Is there deliberate exclusion? Hopefully not in institutions like yours, but one would not know at the higher echelons of power. And as I touched upon, is there a lack of belief in oneself? Are girls not able to believe that they can do as well as boys in science and engineering? This is a nice little article that I came across in BBC, where they asked children to draw the scientist, to draw a scientist. Now, in the 1960s, when children, both boys and girls, were asked to draw a scientist, only 1% of children in the 60s and 70s drew a woman. Why? Because they never saw women as scientists. In the 1980s, almost 28% drew women as scientists. Interesting experiment to perform today, almost 40 years later. By 2013, the actual fact was that women represented 49% of biological scientists, 35% of chemists, and 11% of physicists and astronomers in the US. So why were they being drawn as men in the majority of cases? And this is where I want to appeal to the young men in the audience. Girls, if you ask girls draw a scientist, 58% of them draw them as men. But if you ask a boy to draw a scientist, 96% of them draw them as men. So this is a mindset problem. Am I right? It is a mindset that is ingrained because of your gender from the day that you were born. Now, this is a book which was published some time ago called Lilavati's Daughters. It was published by the Indian Academy of Sciences in Bangalore. And Lilavati was a treatise that was written by the very famous Indian mathematician Bhaskara. And basically, it was a treatise which generally dealt with his poetic conversations with his daughter Lilavati. He just expounded his mathematical principles with his daughter at that time. What this book contains are a number of articles written by women scientists in India on their lives and their careers. Makes interesting reading because it talks about their backgrounds. It talks about how they perhaps had to overcome a number of societal constraints before they could take on science as a career. But one thing always worried me about this book. Should I get inspired when so many women talk about their difficulties and inability to be recognized in their fields or by their male peers? Is this something that we want to speak out about so that things may change in the future? Now, I'm certainly hoping that because I'm addressing a group of very young people who are going to go on to become the future leaders of science, either in India or outside India, that I'm sensitizing them to this reality, which many of your younger women classmates may feel as they progress along in their career. I know for a fact that when I was your age, I don't think I ever felt that women were not equal to men. It's only as you move up the ladder that you realize that there are barriers, those glass ceilings that everybody talks about. And those glass ceilings are erected by the men in the community. And so I'd like the men in the audience now to be sensitive to this issue and ensure that as they progress in their careers, they see that women around them are also progressing to the same extent. Do we acknowledge this imbalance? Well, do we want to do something about it? As long as men remain in power, maybe they don't want to do something about it. And let's take the example of the IITs. This is something that every one of you, all of you have had to take the JEE. I have statistics from 2017. There were about 50,000 candidates who took the advanced, and the topper amongst the girls was at rank number 35. 80% of the students who joined the IITs were boys. 93% are boys in the top 100. Now, something's not okay there. Why is this the case when in exams prior to this advanced, girls were doing definitely better than boys, at least were doing as equally well as boys? What this shows is this particular exam, it isn't enough if you just study to class 12 and study hard. You need to now invest in coaching classes. And you're now back to societal expectations where parents ask, is it worthwhile investing so much money in coaching classes for a daughter? What is she going to do? She's going to get married, move away. Is she going to follow a career? Secondly, how about sending girls far away from home to study? Spatika, I still remember your parents concerned that Mohali was so far away from Bangalore. And would you be able to manage living in Punjab? These are the realities and concerns that every parent has for their daughter. But why are these concerns there for girls? Because of the behavior of men around them. By themselves, girls are perfectly safe in the midst of other girls. But asking a girl to compromise on a choice of institutions is almost a denial of equal opportunity, which, as you know, is a human right. And as I said, if you look at the engineering graduates every year, 30% of them are girls currently. So this is the time for change. We're aware of the fact that women spend a lot more time teaching, mentoring, and doing outreach than their male colleagues. Maybe we and you should spend time on attracting girls to science without considering it a waste of time. As I said, women were very recently only allowed to enter universities such as Yale and Johns Hopkins. Unthinkable if you think about it today. And the argument is given that women don't want faculty jobs. The work is too hard, incompatible with having a life. But that's not true. And I hope people like us who have managed to continue in the scientific profession over many years prove to both the women in the audience as well as the young men that women can have it all, and there is no need to sacrifice anything for pursuit of a career. As I said, one of the things that's a problem as far as scientific activity is concerned is the competitiveness in it. And if women are less competitive than men, is the solution to create a more humane workplace rather than saying that competition is the be all and end all of everything, and if you can't compete well, you don't succeed? Maybe we need to rethink a few things at this point of time. So final comments on this particular aspect of the talk. We know that women are grossly underrepresented in modern science. They have been so for most of history. And the reason is they've been treated as intellectual inferiors and deliberately excluded from it. I gave you examples of all the leading universities around the world that didn't allow women to graduate till the mid-1900s. However, it's being recognized now that because there are more women in science, there is a change in the way how science is done. And I think that's a good thing. Are there clear solutions? Do we want reservations? Certainly not. But we can think about these ideas and perhaps find a way to go forward. And the most important thing, which brings me back to what is required as a scientist, is diversity in your environment. Ideas must come in from everywhere, must come in from different kinds of people, people of different backgrounds, people of different cultures, and of course, women. And therefore, with more women in the workplace, perhaps we may have a more compassionate workplace in future. Now, finally, the last part of the talk that the title wanted me to discuss, COVID-19 and the pandemic. So let me go through this. We can ask ourselves, what did the pandemic mean for us as a nation? Never mind the world. What about us as India? Did we handle it well? How are young people affected? People like you, who must have been sent home maybe almost a year ago, who've not been able to conduct research in your laboratories for long periods of time, who've had to manage with online classes without direct one-on-one interaction with your teachers. Have we learned anything in large from this pandemic? And I'll touch upon some of this as well at the end. And perhaps a question that many of you are asking, especially because you have long lives ahead of you, will the world ever be the same again? Now, I've picked up some of these graphics from the New York Times, excellent interactive maps that are available. Look at this map. This shows you the total number of cases of COVID-19 reported till last Saturday when they put this map up. That's yesterday, I guess. And you can look at the distribution, and a couple of very interesting things strike you. Look at the United States, totally off the charts. The most so-called technically advanced country in the world. India is not far behind, but our population is huge. Look at Western Europe, big red circles. Look at Africa. Africa, where it was felt that things were just going to go out of control purely because of the quality of life that they have. Tiny, tiny dots. And look at the bulk of Asia. Hardly a dot to be seen, even in mainland China, which is where it's believed COVID-19 or SARS-CoV-2 first appeared. What about the share of population with reported cases? Again, look at the United States and Western Europe, off the charts. Huge numbers of the population are infected. Look at India. We are between the 1 in 200 or so per, in terms of the share of population. But look at the US, 1 in 20. Again, of course, you can question data from mainland China. So let's forget a little bit about mainland China. Look at the Democratic Republic of Congo, certain countries in Africa. Now, are you going to attribute this to poor testing? Or is there something else that's going on here? These are the hotspots of infection, as I said, till perhaps yesterday. You still see very high levels of infection in the United States, in Brazil, again, Western Europe. France seems to be doing rather poorly right now. Some of the Scandinavian countries, interestingly, in terms of the number of cases per 100,000 people in the past week. And you see that the bulk of the world, across Asia, across Africa, Australia, of course, New Zealand, seem to be doing okay. Maybe they've cleared, or whatever they've done, the infection seems to be disappearing. Now, if you look at all of this, you might ask, why did India do apparently better in terms of the infection rate, in terms of the lives lost? Was it because of government intervention? You know, that massive lockdown that was called last year around this time? But we know what that government intervention did. The lockdown destroyed lives and livelihood of migrant workers. And I think some of the images that we saw, some of the reports that we read at that time were absolutely appalling. And possibly the result of the government not quite grasping what it was setting out to do when it decided to do what it did. The economy crashed. It totally derailed education. So many schools are still not open in this country right now. We still on campus don't have all our students back. We've recruited students last July. We've recruited students this December, but they're unlikely to come to campus till March or maybe even the summer of this year, provided the infection rates stay low. I don't know how many of you are actually back on your campuses at this point of time. Perhaps the intervention prevented a larger number of infections and deaths, but we don't know that. And I'll come to perhaps why we don't know that yet. Why are there fewer deaths and reported infections in countries like ours? Were a large number of infections asymptomatic? For example, young people may have had a bit of a sniffle and a cough and a cold, which is what they would get anyway, and went on with their lives. Have we reached the stage of herd immunity? Now, how would you know that? Only if you tested every single human being in India, which is definitely not going to happen. Why are we not hearing of villages being wiped out because of COVID? Were they isolated? Not really, because most of the migrant workers went back to their villages once the city shut down. We now have a vaccine rollout. We have a vaccine rollout when actually the numbers have decreased quite a bit. We need to ask ourselves, what are we rolling this vaccine out for right now? Have we achieved a set of herd immunity, which maybe will see us through without a vaccine? Are we progressing according to plan? Is there a plan? Sometimes when I look at some of the statements made by the health minister or people, I wonder, what is the plan? And I am a biological scientist. I should understand the plan, but I'm confused. I don't know what the plan is. Is there a controversy about vaccines? Why was a controversy unnecessarily created? Why have we approved a vaccine for which published data has not been made available as to its efficacy? Was there such a desperate hurry to get that out amongst the people? And major concern is, what are the long-term effects of this particular vaccine? I'm not talking about vaccination in general. Every one of us here would have been vaccinated when we were children. And those vaccines have been tested, tried for many, many years and found to be particularly safe. What about these long-term effects? We have not had these vaccines out for more than 6 months. Do we know what the long-term effects are? Now, I'm not an anti-vaccinist. I'm not at all suggesting that one should not get vaccinated. I'm just raising questions, which is what a scientist does. And here's my concern. What about the younger population? No investigations have been done on children yet. Are we going to vaccinate them? There is a study that's starting very soon in the UK. What are people of the age of the majority of this particular audience? When are you going to get your vaccine? And do you need it? Do you want it? So what's the way forward here? The pandemic has clearly taught us how ill-prepared we are to such infections. This is not the first time that we're going to be faced with this sort of infection. This is the way viruses work, and viruses have been on this earth far, far longer than us. And this is definitely not going to be the last. Was there a lot of panic created in countries not used to infectious disease? Countries like India deal with things like tuberculosis, infectious diarrhea, malaria, dengue, cholera every year. And perhaps if we had better numbers, we might have actually discovered that more people die of those diseases every year than have died from COVID in the past year. And how often can we continue to shut down countries and shut down nations and jeopardize a year of education for our younger citizens who actually were really not that badly affected? If the pediatric population is sorely affected by disease, yes, we need to act because they are the future. But we have really derailed the lives of a number of young people over the past year. And is this what we should have done? So what's the solution to this, young friends? This is something that I've said whenever I've had a chance, that all of you are aspiring scientists, but please cultivate interests in literature, the arts, music. When I mean literature, I don't mean scientific literature. Read novels. Read novels in any language, maybe your own language, maybe in English, maybe in whatever language you feel comfortable in reading in. But start realizing that there is something in life outside of science. And understanding of some of these aspects make you, believe me, a much better scientist. Broaden your horizons. Think about the world outside of India. Think about India too, because India contributes to a very large part of the world in terms of population. But do realize that there are cultures and beliefs that are different to what you may have, and which must be part of your thought process as you go about your day-to-day activities. Think differently, but act scientifically. Don't act based on your biases or beliefs which have not been scientifically validated. So let me leave you with a picture of my cat. And when I've watched her over the last 8 to 9 months, I've realized that she lives a good life. She spends her time in the garden, in the midst of greenery, watching the world go by. And I honestly urge all of you to get pleasure from that and realize that there's a lot in life which the pandemic has taught us and which I think we should think about in our ways of living in future. Thank you very much, and I'd be delighted to have questions or engage in any kind of discussion with the audience.
Thank you very much, Professor Vishwesharaya, for that informative and enlightening talk. And the personal anecdotes especially. I'm sure we've been given several interesting perspectives to think along. So we'd now like to open the event to questions. You can use the raise hand feature in Zoom if you'd like to ask, or the YouTube live stream chat.
Hi, ma'am. Lovely talk. I had a question about the ethical neutrality of science. Let's say that a scientist discovers something novel, which has a potential to be used for destructive purposes. Is the scientist then extricated from the moral implications of their discovery?
Almost, unless he or she advocates that it should be used for amoral purposes. So as I said to you, the question of morality is, again, outside the bounds of science. So much has to do with our cultural upbringing, etc. So, it's a very, very narrow line that you're walking on. Take CRISPR-Cas, right? All of you, I'm sure, are aware of the ability to be able to modify the genome of a particular organism. Now, the discoverers reported a phenomenon. Technologists have taken the phenomenon further. But do you use it to modify a human embryo? Now, that generally around the world, that was considered not correct. But I cannot guarantee that that idea is going to stay that way for a long period of time. Talk about genetic engineering of plants. There are many countries around the world that do not allow genetically engineered plants to reach supermarkets. Many countries in Europe, for example. But almost every single vegetable or fruit that you buy in the US has been genetically engineered. So, these are things which the discovery is made. The fact that you can make plants resistant to certain pests. But how you use that is, I think, perhaps outside the purview of the scientist, because you're then asking him or her to open up about what they believe or what they think rather than the facts before them.
Can I just ask a follow-up kind of to this discussion that you had?
Sure.
So, I mean, when we think about scientists, they are, after all, human beings and very much a part of society, right? So how can
Absolutely.
you completely separate science and society, and how can you disregard ethics or not think
Yes.
about ethics when you come to, like, for example, I mean, I read this somewhere, I'm not sure if it is true, but Da Vinci had made blueprints about a submarine, and he refused to publish it or share it with anyone because he was scared that they would not be used properly.
Mm.
So something similar on that line.
You're absolutely correct. And this is the point that I made during the talk. There is a part of your life which you live as a scientist, which is what you do in the laboratory to address a particular question. But you are a human being. And you also do realize when you do the work that you do, is it ethically correct? I experiment with a lot of mice in my laboratory. We've made transgenic mice. We use them for answering the particular question that we're interested in. But I'm a very strong advocate for animal rights. I would love to protect every single animal on this planet. So what is the issue here? All I can do is ethically sacrifice the mice, convince myself that the experiment that I have to do has to be done in the particular way, and not just because the mice are available for me. So I agree with you. These are very, very gray areas, and you cannot divorce yourself from society. However, there are certain things that society impinges on you, where as a scientist, you may have an opinion. And it's a scientific opinion. If somebody tells us that if you take a vaccine, you're going to grow wings, you can argue that that's not going to happen. But your own beliefs and your own moral compass is your compass. And you're going to have to deal with that, especially if you're working in the area of perhaps physics or biology, where you realize that some of the discoveries that you make may actually have the potential to be misused by bad actors, as they say. There is no right or wrong answer here.
I want to ask how you said something about literature. You said literature would help you broaden your perspective. I mean, I haven't read much of literature, but so far as I've read in school, like Gulliver's Travels, yeah, Invisible Man, and other one. So how would that help me become a better mind?
Okay, so what you've been told to read in school is one thing. What you're told to read in school is usually because it's literary, okay? You start reading novels, and what you see is the way people behave in response to a certain condition or situation around them, okay? Depending on the kinds of novels you read, the individuals in such a novel have thoughts which are expressed by the novelist. They act in a particular way with the people that they meet. Essentially, what it does is tell you that human beings are different. You cannot say everybody has to be the same or everybody is the same. Now, why does this become important? Some years from now, Abe, you're going to be running your own laboratory maybe, or you're going to be working in industry, leading a group of people or a team of people. Every member of that team is an individual. And it's important for you to realize or understand human behavior so that you're able to get the best out of the people working for you. And the only way to understand human behavior is when you observe human behavior, either in your day-to-day interactions with your friends or by reading books. Because books are away from you, they're distant from you, they're not related to somebody you know. Every novelist takes great pains to say that the characters in his book or her book are entirely fictitious. So that is why reading novels are important. That is why reading Shakespeare is so important, if you can understand what he writes. He writes about almost every single aspect of human behavior in his plays, and he writes about it poetically. So you have to think about the words he's writing. They're not black and white. And you have to understand the agony that his characters are undergoing, or the pleasure that they're undergoing. It's that ability to empathize, not sympathize, but empathize with another human being that makes you a good human being in terms of being able to run an organization. There was a question that Akshita had, and I want to take this question because first question from a girl, which I'd like to hear. She asks, in government institutions that are funded by the Indian taxpayers' money, do scientists have an obligation to conduct research that directly benefits the public, or isn't high up, or research that isn't high up in the ivory tower? Money is scarce, so should some research be prioritized over others? Absolutely, yes. And the government puts out very specific calls in particular areas. For example, I think in the last year, the government must have invested quite a bit of money on COVID-19 research in terms of diagnostics, etc. There are many ways of looking at this. One does not know immediately whether the research you're doing is going to benefit mankind in future. So therefore, completely saying that right now I have to solve the problem of drinking water in villages or electricity in villages, I'm not sure there are scientific solutions to that. We all know that there are political solutions to that. So science can't divorce itself completely from the political system. Unfortunately, the political system many times thinks it can divorce itself from scientists. So it's a good question. Again, I think ivory tower research is necessary. Much of the physics that was done in the early 1900s was ivory tower, and much of theoretical physics still remains ivory tower. We are never going to see a black hole, but we know they exist. And so therefore it's kind of difficult to think and completely say that in countries like ours, scientists should not be doing such kind of exotic research, because otherwise we're always going to be borrowing ideas and always going to be borrowing theories and philosophies from people outside the country. Yes, we have problems, but many of the problems of India can be solved by political solutions and don't necessarily require scientists to come in there, because the science is already there. You just provide clean drinking water, you get rid of diarrhea. You improve the health of an individual, he or she doesn't have tuberculosis. It's all out there anyway. Thank you.
We'll be taking the next question from Ratul.
Hello, ma'am. Very honored to attend this talk by you.
Thank you so much. Honored to be here.
Yes, ma'am. And I have one question regarding the verifiability of scientific fact. Mm-hmm. You mentioned that if an experiment is performed that yields a particular result, which proves a certain fact, it has to be, like, each time the result of the experiment has to be the same for that fact to be acceptable.
Similar
for that fact.
Similar. Statistically similar. Okay. It's, depending on the number of variables you're dealing with in an experiment, you will never ever be able to reproduce the exact same result. And actually, if students come and show me, especially in biology, exactly the same result in the second experiment, I get nervous. Because, biological phenomena are highly variable, and there are many variables which we're not able to control. So it depends on the area of research that you're in. So for example, if you're a chemist and you mix two compounds in identically the same amounts and you cook them for identically the same amounts of time, you should identically get the same product. You should get the same product and the same yield next time, right? Provided everything was kept in control. And in physics, maybe, you should definitely get the same number every time, because you're putting in numbers into equations and numbers come out. And 1 + 1 will always be 2, right? It cannot be 1 + 0.1 sometimes or 2.2 sometimes. 1 + 1 is always 2. But in biology, unfortunately, we don't have precision to the level of 1 and 1 or 2 and 2. And therefore, you're going to get variation. So when I talk in terms of reproducibility or verifiability, it is within the statistical constraints that you put in fields like biology or medicine, for example. You know, when they tested the COVID vaccine, they tested the first rounds were on certain like 35,000 or 80,000 people. When we do experiments on mice in the lab, we certainly don't use that number. We use maybe 6 mice, 7 mice, but we reach our conclusions. Why? Because the environment of these mice is much better controlled than the 30,000 humans you go and inject with a vaccine, right? So you have to understand the question that you're asking and the kind of science that you're doing to think about variability and reliability.
Right. So similar results.
Similar.
So, right, I wanted to ask about what if an experiment, that experiment which proves that fact becomes unperformable due to whatever reason?
How do you know that the result from that experiment was correct then? You really have to question it. You have to question it. If you're not able to reproduce an experiment, there is a flaw in the design of the experiment. It is extremely important that, you know, again, I'm talking from where I'm coming from, which is as a biologist. If your experiments are not reproducible, if 5 mice this year behave in one way, and next year the same 5, or not the same 5 mice, another 5 mice behave differently, I cannot make a generalization. It's my responsibility to figure out why the 5 mice this year behaved in a particular way, and next year why the 5 mice may behave differently.
What if there are no mice at all?
Whatever it is, whatever you may be doing, what do you want to talk about? Plants, insects, snakes, whatever it is.
Okay.
The more variables that are there in an experiment, the more number of times you need to do the experiment to get it within statistical relevance. However, if you're an ecologist and you're out trying to identify a very unique type of bird that lives only in one tiny area of the Himalayas, and one day you do spot one bird, you can report that.
Okay.
It's perfectly fine. So as I said, it's completely discipline dependent in terms of the rigor that you apply to this so-called reproducibility. You say you've seen the bird, but if somebody else comes the next day and doesn't see the bird, if you've been honest, that doesn't at all negate the observation that you made. But you need to back it up, huh? You need to back it up with a photograph or something. You can't just say, oh, by the way, I saw that bird. That's tough. You're not going to be able to convince too many people about that.
Thank you, ma'am. That was
Pleasure.
the answer I was looking for.
Pleasure. Does Naman have a question?
Yes, ma'am. Good evening.
Good evening.
It was a lovely talk.
Thank you.
You talked about that we all have inherent biases when we join the field of science, and
yes,
we should try to be as neutral during the research as much as possible. But
yes,
but if we are working on a field that has not much already existing research material available, so some of our biases automatically come in, and if we are the pioneer researchers in that field, then the first literatures that we are producing will be biased. So how do we avoid those, and how can they change the route of further research?
It's a nice question, but I want to make one thing clear. There is very, very little left in the world that we don't know something about. Okay? I think somebody said that all their discoveries have been based on the shoulder of giants. So there's very, very little that you can really discover for the very, very first time, which no one has reported in some way or another, something related to it, okay? You may make a discovery which is different or tangential or unique, given the available information that there is. But if you mine literature sufficiently well, it's very unlikely that you'll never find anything related to what you're doing. Now, when it comes to bias, we are talking about bias in terms of interpretation of the experiment, okay? And bias in terms of execution of the experiment. There cannot be bias under those circumstances. The way you design an experiment is based on scientific principles. The result that you get must be interpreted based on available scientific knowledge. Where does the bias come? In the discussion sections of your paper. There you can say, I've discovered the cure for cancer. Now, your reviewer may tell you, you have not discovered the cure for cancer, but you found that if I inhibit that particular protein, cells stop replicating. Do you get the distinction, Naman? Your bias comes in the way you present your data, but the execution and the results that you get must be bias-free, even if there is very, very little information available. There are scientific approaches and scientific procedures that are well worked out, and they have to be adhered to in whatever way you do your work.
Yes, ma'am. Thank you.
We'll be taking the next question from Kratika. Please go ahead.
Hello, ma'am. This is Kratika. It was a really nice talk. So,
thank you so much.
Yeah. Ma'am, while concluding the talk, you mentioned how significant it is to cultivate interest in literature, arts, and music. But do you think primarily science-focused institutes like ISERS, ISC, give enough importance to these pillars of literature and arts? And if not, how can that be sort of unified into the premier scientific institutions?
So I'm sure not many of you would have read the new education policy that the government of India has put out. And I know about it because I was part of a committee in the institute to look into it very carefully. And the intention spelled out in that new education policy touch upon exactly what you've mentioned. That is, this distinction between arts and science should not be there at the undergraduate level. And they're far more supportive of institutions, even science institutions such as yours, setting up a very strong arts department or an arts faculty where students will be exposed to things like literature, music, etc. Now, many of the ISERs have already been set up, and to now bring in dramatic change, even in an institution like mine, for example, is not easy. But I completely appreciate where you're coming from, and I think this is one of the major drawbacks of our educational system in India. This is not true in the Western world, where you can be a computer science graduate and learn to play the violin, and that's valued as importantly as whatever you do in your computer science class. This is a limitation in our education system. We need to do something about it. The government says that it's going to try to do something about it, but until then, I think it's largely left to the individual, and that's the reason why I brought it up in this talk. Because what I'm trying to do is to reach out to a group of young people who are right really at the beginning of their careers. And therefore, their thought process or the way that they go ahead in life can be changed based on what I don't want to call what I've said advice. I can only say it's a recommendation. And there are some of you who are going to follow that and try and make an effort to read novels and plays and poetry. There are some who really don't have interest in that, which is also perfectly fine. But let me tell you that the best scientists in the world, if you look at their CV, or if you look at their, something written about them in popular articles, you'll find that apart from the science that he or she does, they are outstanding musicians, or they write novels on the side, or they write poetry on the side, or they're photographers or painters. So what that shows you is the breadth that the human brain can accommodate. And it's that challenge that I'm putting to all of you, that yes, it's important to do well in your exams, it's important to do science, but there's another side of your brain, left-hand side, that actually also needs to be nurtured in many of these ways.
Right. Yes. Thank you, ma'am. Thank you so much.
We'll be open for 2 or 3 more questions. Can Divya go ahead?
Oh, hello, ma'am. I hope you are doing well.
Hello, Dibya. Is it the Dibya? My Dibya?
Yes.
Oh, very nice. Okay. Hi there. Good to see you again.
So I was wondering,
Sure.
like, you spoke about the problem with diversity, and
did we lose him?
I think my video got stuck.
Yeah, I think we lost you for a minute. Yeah.
Okay. So you spoke about the problem of diversity when it comes to the scientific field. So as students right now, how can we help improve the situation? Because I think the problem kind of is on at a higher level with PIs or advisory committees like that.
Totally.
But as students, how can we help improve the situation?
I think as students, you should call it out. Okay. So for example, if you perceive instances of bias, and this bias could be against women, this bias could be against, I don't know, transgender people, gay people, it doesn't matter. If you, religion, there's so much bias against religion and the religion that you belong to. If you see bias, you should call it out. It's only when younger people make a noise that people listen. I agree with you completely. You know, this talk that I've given you, where I picked up some slides from a talk I gave a couple of years ago on women in science. I gave it to an audience of exactly as you said, PIs, senior people. I don't think it made any difference whatsoever. And as I was preparing for this talk, I thought to myself, let me bring this to the notice of the younger generation, because one day, Dibya, you're going to be in my place. One day you're going to be where I am. And what you do in those 25 years when you're running a lab or, you know, taking part in committees is dependent on what your mindset is and how you view things. It is appalling that we still see symposia in India where there are no women speakers. In the biological sciences, it is appalling, but it's happening. But people are calling it out. There is something called bias watch. People are calling it out. They're saying that, look, that symposium had no women speakers, even though biology is represented by 40% women scientists. Why wasn't there a single woman scientist called for that meeting? So call it out. Speak up about it if you see biases in your environment. And obviously, try and avoid bias in your own way of dealing with people. Very interesting. I remember when I started my laboratory, I had a very senior collaborator, a Swedish person who was working in the area of research I work in. And one day he asked me, do you have boy students in your lab? Do boys join your lab for a PhD? And I looked at him and said, yes. I mean, actually, at that point of time, I think I had more boys than girls in my lab. I said, why are you asking me that? Because it never struck me that it would be a problem. He's from Sweden. And he said in his wife's 25-year career as a top-notch scientist, she never had a male student. This is Sweden, okay? This is India. So in India, I can claim that I've never felt that boys wouldn't join my lab because I was a woman researcher. They may not have joined my lab for other reasons, but they didn't join my lab, not because I was a woman researcher. So these are, you know, the subtle biases that you can call out if you see them, and you have to call them out. Otherwise, they will perpetuate and they will continue.
Thank you, ma'am.
Thanks, Divya.
Thank you, ma'am. We'll be taking the next question from Dheer.
Good evening, ma'am. Thank you for the very great talk. I want to ask a question regarding science communication, which I apologize if you have covered this point before. When we see today that in several fields, pseudoscientific and non-scientific endeavors are gaining more and more gaining an equal footing all around the world. It is imperative for people associated with research in any way to question new and ongoing research to either improve it or to point out whether it's say effective, etc. Sorry. For example, research ongoing around vaccines and vaccine efficacy, as some points you brought up, that whether young people should take it or the long-term effects, etc., etc. Those questions are necessary to be asked of any such research. But when any form of questioning of modern scientific research is used as a tool to demonize science in media, such as saying that, see, that even scientists are questioning this, that means that this pseudoscientific or non-scientific alternative is more grounded than these doubtful scientific endeavors. How do we effectively question and improve upon ongoing research without it being demonized in science communication to the public, or without instilling fear among laymen that this process is a very natural part of ongoing science and it does not bring down the efficacy of the ongoing research?
Education and initiatives that you're trying to do here by setting up this magazine, Inventa. You're going to try to communicate science and scientific discoveries to a set of people who perhaps are not scientists. The only way that you can overcome this kind of thing is by just doing more of what you do correctly. If one gets embroiled in trying to change the attitudes and ideas of a large section of humanity, it gets very difficult. You know, the classical example is what's happened in the US. Wearing of a mask was made a political statement. There were outrageous curative things for COVID that were espoused by the President of the United States. Now, fortunately, in our country, the politicians have largely toed the line that the scientists are speaking. And I found that actually an extremely interesting observation over the last year, in the way that I've seen scientists actually being talked to and interviewed related to virus, etc. So I think it's just keep doing what you're doing, keep spreading the scientific message. If there are a set of people who just don't want to listen, there's very little you can do about that. It might help if you tell them, for example, that the cell phone that they're using came out of science. It didn't come out of magic. It came out of understanding communication principles, electrical communication, signal theory. So if you give them examples of where science has improved, so-called improved in inverted commas, the lives of people, they may then realize that, look, science has value, and maybe we could pay a little bit more attention to scientists. But it's not easy. It's not easy. And I'm actually pleasantly surprised by the way the Indian community has, even though we're supposed to, have a very large number of illiterate and uneducated people in the world, you actually see that our people have generally responded favorably to scientific directives that have been set to us. Unlike, in all honesty, many countries in the West, where they're supposed to have a greater understanding of some of these principles. You just have to keep doing your science, and you just have to keep speaking about your science. That's all.
Thank you very much, ma'am, for that answer.
Thank you.
So we'll be taking the last question from Spurti.
There was one question from Buddhaditya, and I want to answer that because I think he's one of the organizers, right? So I can't ignore the organizer of that.
Okay.
I'll take his question. With regards to the objectivity of research, is there some way to ensure objectivity in the peer review process? Oftentimes in research, some ideas become fashionable and research into conflicting directions sometimes get biased. Is there some way to ensure that this not happen? Is transparency in the peer review a viable solution? What if authors are provided with the identity of the reviewers? Are there pros and cons? Oh my goodness. This is a discussion which innumerable journals are having right now. And many of them have experimented with some of the things you've said. Open review, showing if you look at Nature, for example, in most Nature papers now, you actually identify the reviewers, but they must be willing to be identified. So the option lies with the reviewers. There are certain journals, such as some of the EMBO journal, for example, which actually puts out the entire review process in black and white for any reader of any paper. So journals are experimenting with many of these approaches. Completely abolishing bias, well, we're all human beings. So this is the problem. How much of your humanity can you remove from being a scientist? As a scientist, you're supposed to be impartial and without any kind of bias, and you must be that way when you're reviewing scientific matters. It's not easy, but all of these things you've suggested are what journals are experimenting with right now. And we'll see how it works out. We'll see how it works out. Spurti, shall I take that question, Spatika?
Yeah, that'll be the last question.
That can be the last question, maybe. How can we increase access to science research for students who don't belong to prestigious institutions in India? Yeah, this is really, really very sad. I think there are large sections of our society who really don't have access to science, and the schooling doesn't provide them the environment. Again, as I said, these are all political decisions, political will. There is enough money in India to be able to set up good schools, set up good research laboratories. I think the internet, to those who have it, is breaking down a large amount of barriers. And if the country can get connected a little better in all regions, it's quite possible that at least if not directly in your school, you can explore what science is through the internet. But it is difficult. It is really difficult. There are efforts by many of the academies for researchers to move and talk in some of these smaller areas. But you need to have power in the local language then, because many of these children would have been educated in the local language. And science, at least Indian local languages, are not terribly conducive to explaining scientific concepts. This is not necessarily true for Western languages such as French or Swedish or anything. They can talk about science, German, for example. They can talk about science without having to use a single word of English, because they have the words in their language for many of the things one needs to say. It's far more difficult in Indian languages, and therefore you need to keep on introducing these scientific words, which kind of don't really communicate. But yeah, it's a very, very nice question, and it's an unfortunate condition in our country. We do need to reach out, and maybe some of you young people can perhaps visit villages near your ISAs and spend a day just talking to students and showing them simple little experiments, getting them excited about it, and hope that they find the avenues they can to come up.
Definitely, ma'am. Thank you.
Thank you, Spurti. Yeah.
So I'd like to close off the question round, but thank you so much, ma'am, for agreeing to participate and really teaching us a great deal today. So I'd now like to invite Revati Menon, the managing editor from ISER Tirupati, to conclude today's ceremony with a vote of thanks.
Hello. Good evening, everyone. Well, to conclude today's launch, I would like to present the vote of thanks on behalf of the editorial board of Inventa. It is an honor and a privilege for us to have Professor Sandhya Vishwesharaya here today, and we are immensely grateful for that. It's always a delight for us to attend your talks, ma'am, and we have discussed so many topics today that I think each of us has found something to think about, especially with regard to diversity, inclusivity, and in general compassion for other people. Well, Inventa, was first discussed as an idea way back in July 2020, right in the middle of the lockdown. And when we started out, we didn't know how much was possible and if we were reaching too far. And this transition from ideation to actualization has been made possible with the timely aid and cooperation of countless people. We are grateful to the directors of all the participating institutes, the 7 ICERs, IISc, NICER, and CEBS, for extending their support to our fledgling initiative. We thank Professor Satyamurthy and the editorial team at Resonance for featuring us in the January 2021 issue. And we would not have been able to move forward with our plans without the guidance extended by the faculty members of our respective institutes. And in particular, Dr. Jishi Varghese from IISc Thiruvananthapuram, Dr. Joe Sebastian from IISc Berhampur, Dr. Vasudharini Devanathan from IISc Tirupati, Dr. Amiya Bhagwat from CEBS, Dr. Vinita Gowda from IISc Bhopal, Dr. Shivajit Bandopadhyay from IISc Kolkata, Dr. Devasmita Pankaj Aloni from NISA, Dr. N.G. Prasad from IISc Mohali, to whom we are especially grateful for assisting us through the proceedings of this launch. So while we were figuring out the way forward, the design team was hard at work, and they have truly come through, adapting, conceptualizing, and creating, as per our needs and the needs of the moment. Our internal teams of editors in each institute have been instrumental in readying the magazine that we are launching here today. And we're also deeply thankful for all those who volunteered to send in their contributions to kickstart this initiative, and we hope to see more such contributors for the next edition. So we will have the issue on our website where you can download our magazine. It will be up. And you would also be able to find some more information about this year's edition, as well as the people that are behind it. Well, thank you for attending our launch, and we hope you enjoy this edition. That's it.
Thank you very much, and all the best to all of you.
Thank you, ma'am.
Just a quick announcement before we finish up. Our website is currently experiencing a lot of traffic, so please go have a look as and when. It should soon be up. We've apparently exceeded some quotas. But otherwise, thank you very much for attending, and have a nice day.
Thank you very much, Spatika. Bye-bye.